Welcome to the Masters of Engineering podcast. Cool products, the people who develop them, and how they do it. My guest today, very exciting, Braden Ball. He is the co-founder of a stealth mode startup called Threaded. You probably haven't heard of Threaded, but I'm sure you've heard of his previous companies because he's worked at Rivian and Tesla and Amazon and a bunch of other cool companies. He's been involved in launching some of the coolest electric vehicles in the world. Braden, welcome to the podcast.
Hey, John, good to be here.
Great to have you here. And so, before we get to your current company, which I know you're probably not going to say a lot, but we'll get to that a little later.
Mhm.
Can you tell us about your background leading up to it? Where did you come from? And I mentioned some of the companies you're at, but very interesting background.
Yeah, for sure. Yeah, I started my career as a manufacturing engineer, actually. I studied manufacturing engineering technology. Fresh out of the gates, I went to Caterpillar as a manufacturing engineer in one of their leadership development programs where you go in and get a bunch of different roles kind of throughout the company to understand how a factory works and how you can kind of set up for your career. After that, kind of went to grad school. During grad school, I spent some time as a fellow with Amazon, which was really cool. To be able to see how they use data in their operations, which was just very eye-opening to me to see the power of that and the power of technology as applied to operations. After grad school, went back to Caterpillar for a stint, then was able to, as you mentioned, spend some time at Tesla, where I did new product introduction. So in that space, I was able to launch everything from junction boxes up to the Model X into the factory. And it was a super exciting experience to be able to kind of be on the front lines there as we got so many of those products up and running into production and into customers' hands. After that, spent some time in the additive manufacturing space with Carbon, working with them and with Adidas. They have a product called the Future Craft 4D, which is a 3D printed midsole for their running shoe. So I was able to be a key part of that, getting that up and running as we launched operations, as we developed the product and launched operations in California, Germany, and in Asia. And then most recently have been with Rivian, where I was the director of vehicle launch there as we got the R1T, the R1S, and all the different products up and running as Rivian started to build. And now, like you mentioned, I'm working on a startup. I've spent a lot of time in this space, kind of working through what we need to do to get products from concept and prototype up to scaled up manufacturing. Found a lot of challenges along the way, and so working on a startup to hopefully help others go through that process and do it more efficiently.
Well, that is an amazing background. I know one that a lot of our listeners are just could probably listen to stories from your experiences all day. But just to start a point of discussion, Model X product launch at Tesla. Now we've all read in the media that that was a crazy, frenzied
Mhm.
product launch. It was it as crazy and frenzied as the media makes out?
Yeah, I spent plenty of nights living at the factory. Spent a
You
lot of
did.
time there. Yeah, I slept there. Elon's not the only one that gets to claim that honor. So there's lots of people that did actually. It was a very difficult thing, and we like to look at the Falcon Wing doors and say, oh man, that's so cool, but also so hard. But it's not just the Falcon Wing doors. There's all kinds of other processes and technology that went into that vehicle that make it incredible, but also made it very tricky to kind of stitch everything together to be able to get it up and running consistently in the factory.
Yeah, was the Model X the world's first electric SUV or the first mass, reasonably mass produced one? It's the first one I know of.
Yeah. I think it's the first one that you would look at and say, "Hey, this is an SUV and it's a vehicle that's still around today and still continues to be compelling."
Yeah, those gull ring doors are so cool. I've driven one. How much did other experiences prepare you for that? Like you were at Caterpillar, more old time kind of company,
Uh huh.
MIT, Amazon by then, but even Amazon's a pretty old company compared to Tesla,
Hmm.
right? And so how did that prepare you?
I felt as well prepared as you could be. I think when I started at Tesla, I've been fortunate enough to have done functional roles in manufacturing engineering and production control. I'd ran operations at a large scale manufacturing facility with Caterpillar. I understood all these different functional groups. And when I started, my boss said, okay, your job is to get manufacturing lines up and running, and you need to go as fast as you can without falling down. And it's like, oh, okay, like I guess I can do that. And it was very much a first principles based approach. Say, okay, you understand what all the nuts and pieces are in order, if in order for manufacturing to work, which I'd seen at Caterpillar before. I'd seen how operations work at Amazon. And so, the challenge was getting from, none of that system is in place functioning together yet to a running efficient or relatively efficient system that can then be continuously improved upon. And so that prior experience really helped me jump into a very ambiguous situation, which was, we talk about the Model X. The first product I launched was actually a junction box that had 14 light items on the bottom, right? Like not super complex.
14, I'm sorry, 14 what on the bottom?
14 line items, so 14
Line items.
components,
Okay, on the
right?
bottom.
And so the
All right.
very first product I launched at Tesla was relatively simple, right? But kind of bring in all of my background about how a factory should work, what do the operations need to look like so we can build that consistently, that then I could kind of pull the cross-functional team together, get that line up and running so that way it could do what it needed to do as a component of the Model S. And then from there was able to build out and kind of get more experience in different components of the vehicle, things with supercharger, things with all the charging infrastructure, whatnot. So that by the time I went to work on the vehicle level, I understood kind of all the components, where they're coming from. I'd seen the way a large scale factory works. And, it worked really hard with a lot of really amazing people to make stuff happen. And so kind of doing that in a larger context, really was, yeah, I guess to answer your question, yes, like that background is what made it possible.
And when you say you launched a junction box as a product, that's not a product that we could, go down to the Tesla
Uh-huh.
store and buy, right? I assume that's an internal deliverable or
Yeah, it's an internal deliverable. So one of the, I think, really cool things about Tesla that I think is sometimes appreciated, but oftentimes is underappreciated, is the level of vertical integration that existed, especially in those days with Model S and Model X, and it still persists today with how much of the products that we had to make ourselves and how to set up scaled up manufacturing lines to do. Like oftentimes you think about the automotive supply chain or what it takes to make a vehicle, and you're like, okay, I've got a body shop, I've got a paint shop,
Mhm.
I've got general assembly end of line, and then I probably have some type of powertrain. If I'm in an internal combustion engine, I've got the factory that's making my engines and transmissions, or if I'm in an EV space, I'm making my drive units and my battery packs. Pretty much everything else you can source from tier one and tier two suppliers. At Tesla, we're getting this up and running where EVs, they weren't a large scale thing. You couldn't go out and say, hey, I need to get high voltage cables. I need to get these junction boxes at automotive scale and automotive quality. There weren't suppliers that did that. And so because there weren't suppliers that did that, and at Tesla, we wanted to control things very tightly. We said, okay, well, we're going to do it ourselves. And so, that resulted in us setting up many, many production lines for
Mm,
many, what I would consider a product, but that product goes
mhm.
into, it's a component of the next level product that ultimately ends up in the consumer's hands. And so kind of you go through this a bunch of different times with all kinds of different permutations, from junction boxes to center display units to wall chargers to drive units to battery packs or whatever. And then you're able to put that all together into a cohesive system into the final vehicle.
And so you call it a product even for internal consumption as if you were a supplier. Are there a couple items you'd say, these are some takeaways that you learned from Tesla that they should know about? And maybe, these are things definitely do, and these are things that we did at Tesla that you should avoid.
I
What
think
is
the thing
that?
that's top of mind for me is the importance and acceptance of failure in the whole process, right? Like
Mm,
when I first started, I was told, okay, go as fast as you can without falling down. And this idea that, okay, we want to avoid failure. We want to just be successful so we can go and do this stuff quickly. But necessarily when you're doing a product um, like a Tesla, or really any product where you're doing something new that hasn't been done before, you're not going to get it right the first time. And so you're going to
mhm,
try and pull all this stuff together, and it's going to result in failure. And that failure can be very discouraging, because you're like, oh man, oh, this whole world fell around. But one of the things I learned over and over again is that no, the failure, like it's the way, right? Like that's what development is. Whether you're developing a product or a process or a tool, it's figuring out how to make this thing work. And in almost necessarily, you're not going to get it right the first time, and so you have to learn from that and then propel on to the next thing and keep processing forward. And I think that's one thing that I had to get used to in the Tesla context, because we all know it's high pressure. You're making amazing products. We've got really hard timelines. We're doing things that are amazing. The challenge is not that if you don't get it right the first time, like you're terrible. The challenge is like, okay, what did I learn? How do I figure out how do I pivot this forward and make it turn this thing into a success? And the sooner you can learn to accept that everything's not going to be right the first time you try it, the better your ultimate outcome can become, because you can kind of accept that I'm going to fail, and the way I'm going to learn, I'm going to do better and move forward. Um, and so that's like
yeah, that
primary. Um, the next thing that I think about is thinking out problems from a first principles basis. So really defining what is the problem
mm,
that I'm solving, and then am I using the appropriate tools to go after and solve that problem? Whether that tool is an actual physical tool, whether it's something with technology, whether it's people, making sure that you're deploying the right things to solve the right problem. Oftentimes, it's really easy to look at things and say, "Oh, it's automotive. This is the way that automotive does something,"
Mhm.
and
Mhm.
and that's actually
Yeah.
a really it can be a really dangerous way to approach a problem, because in automotive, like, that's a very broad spectrum. And actually, while you may have seen something solved a certain way in automotive, it doesn't mean that that's the only way that it's solved in automotive. And that way in which you saw it solved might be a very different context from which you're trying to, in which you're working. And so, kind of really understanding the problem at a first principles level, like, what are we trying to do? And then applying the right tools to the right time. Like,
Mhm.
for example, at Tesla, we were small. A lot of big automotive companies rely on big systems that have been built over decades, like
Yeah.
many decades, in order to operate. And oftentimes we like to think, oh, we develop and launch this product so much faster than the traditional automotive industry would have done, right? And while yes, that could be a true statement, what I find much more compelling is not necessarily just the product, but like that full manufacturing system. The traditional industries have had decades over which they've built up their processes and
Yep.
systems to be able to execute consistently. And so when you're starting from scratch, you're like, okay, I can't just rely on what somebody else has done because that's the way they've done it for the past 20, the past 20 years, and that works in their system. Like, we don't have that system. It's not necessarily going to work for us. Instead, I've got to understand what I'm trying to solve and put the appropriate tools and solutions in place.
So, first principles and embrace failure. I think those are great. When you say go get whatever tools you needed, I find sometimes in bigger companies there'll be rules about what you can use and not use. Were you free to just say, "Hey, we don't like this vendor. I'm going to go. I got this new vendor for a molded part." I'm just curious
Yeah, yeah.
how much latitude you had to choose things.
Yeah, I mean, when you're getting up and running something, you almost by necessity have to be scrappy. Like, you don't have the same resources that everyone else does, so you don't have this huge approved vendor list that says, "Hey, you can go and do these things." We sometimes like to trust our pilots, as we have to fly close to the trees, right? Like, we're not saying, "Hey, we're going to set on autopilot
Mhm.
and just fly at 30,000 feet." Like, by
Great line.
necessity, we
Great
have
line.
to be close to the
Yeah.
trees, and we're going to trust our pilots, right? And so, two parts of your question, like, one, when you're trusting your pilot, your pilots aren't just going to say, "Hey, I don't like this for whatever reason, so I just want to switch over and could just change willy-nilly," right? Like,
Uh-huh.
typically you're understanding, "Hey, I have a core problem and it's not working. Either I'm not keeping up to scale because of this tool is there, or this vendor, or whatever I'm working with." um, and so I need to understand what that problem is. And then, once you understand that what that problem is, what's the right solution? Do I need to resource it? Do I need to actually go understand what's happening with the supplier? Because
Yeah.
oftentimes supplier issues are a communication problem where you actually just need to go on site and make sure you're all speaking the same language, and you can move forward. Or is it that I actually do need to go deploy a new tool? And once you understood, here's the core problem that I'm trying to solve, and here's the path that I want to go to fix it, then it's not difficult to kind of get approval, if you will, to kind of go and do the right thing. Now, it would be difficult if you're like, "Oh, I just don't like that, so I'm going to go spend money because I think that I like this guy better." Like, yeah, that would run into a problem because it's actually not helping you solve the core problem. But if you know what you're solving, you're going after it. I find that typically you get latitude to go kind of do the right thing, and find the right solution.
What you said about the pilots in the trees, great point. And you said something really key, which is you have to trust people that the pilots aren't going to make willy-nilly changes, that the you of the world, sometimes companies don't give people latitude to be agile, make changes because they're worried about getting abused. So you have to have the right people who you can
Mhm.
trust, and the people have to be reasonable. So Tesla, fascinating chapter. I mean, that would be enough to just talk about Tesla, but we've got some other chapters of your career here that I really want to make sure we cover because, I think probably about 100% of our listeners probably do some form of 3D printing or another
Mhm.
additive. So let me move on to your time at Carbon,
Yeah.
which can you tell us? I know a little about Carbon, but for the benefit of the audience, can you tell us what Carbon does and what did you do at Carbon?
Yeah, for sure. So Carbon does, generally speaking, additive manufacturing, and I would say for production. So oftentimes we've talked about 3D printing, and typically there's, a handful of, like, we love 3D printing. It's great. It can make really cool geometries. It can be great for prototyping, but there's often some challenges in turning it into the 3D printed components into a final product.
Yep.
One is that you say the material properties aren't quite good enough, right? Like, I can't make something that's going to be robust and durable enough to go out in the live world and be my product. I can make something that looks like, feels like, but not something that like behaves like over the long term. The next is that they'll say additive manufacturing is too slow. Like, I can't keep up with required cycle times for scaled up manufacturing. And then the last one is just say you can't quite hit the specifications. So you can't hit the surface finish and tolerances in order to make a part that's going to be a part of a complex assembly. I can make kind of one-off things that I'm going to put my hands on, but once I scale up and try to build lots of them, you're going to have a hard time doing that. And what Carbon came in and did is said, well, actually, none of those things are requirements of 3D printing. They're just kind of the legacy nature of kind of what exists kind of out in the world. And so they, came up with a technology that could both print fast. They created materials that could have really great mechanical properties. Like one of the products that we did was a running shoe with Adidas. I wear my pair all the time, and there's not much more durability testing than stepping on it kind of all day long, every day over multiple years that you can go through. Yeah, I think Adidas is an amazing company, and they are very they're athletic but also athleisure, and there's a fashion component to what they're looking at, right? And so as a result of that, they're always looking for new ways to differentiate their product on both the performance basis as well as on the styling basis. And so they saw, wait, 3D printing, this is really cool, like we could do a lot of different things here. Now, the idea of being able to create a 3D printed midsole in footwear, like the idea has actually been around for quite a while, where they could say, okay, this would be really cool things when you think about customized designs, customized sizes. There's lots of cool things you do with 3D printing that you can't do with traditional tooled manufacturing. And so this idea of footwear and 3D printing or additive manufacturing has kind of existed for a while. And then as Carbon came along and had the technology that could start to deliver on that promise, and Adidas was kind of, okay, how can we do with this? It was really kind of a match. That partnership was formed right before I joined, and I was joined to kind of help lead that partnership. Was who took it from, okay, we've got the concept, we know that we can do this, now we got to go figure out how we pull all the pieces together to go and do it, is really kind of where I spent most of my time there.
So you've had all these great experiences already: Amazon, MIT, Caterpillar, Tesla. Now you go to Carbon, and you obviously help them with the Adidas, getting the Adidas shoe to reality. Did you learn anything at Carbon that changed your thinking about product development, or learn anything about additive that changed your thinking about product development?
Yeah, I think a lot of it solidified a lot of my thinking about product development.
Okay.
And so, one of the really cool things about Carbon was we weren't just launching like one new technology, right? Like we had to get Adidas's design and their technology of their product kind of up and running. We had to get all of our materials. So the material science, the team there that's literally like inventing new polymers that can meet the mechanical specs that you need to. We had to develop our hardware that can execute this and set up the system to drive it. And then we had to develop the software that would all kind of stitch everything together. And those ideas of thinking about this big product development process is not just kind of discrete items that are just going to happen to work together if you do them right, but really it's a big system that all has to come together and work in
Mhm.
sync. Really got reinforced in that space, as well as the idea of like learning through failure and kind of working through that, because that's one of the great things about additive manufacturing is you can actually fail really, really fast. It's really easy to go through cycles and
Yeah.
iterations if you're
Yeah.
printing things, and that helps your learning just accelerate tremendously.
So now let me move on to Rivian. Now,
Mhm.
I assume many of us out there um, are fascinated by watching the Rivian journey for a lot of reasons. And now we see a lot of Rivians on the road. At least I do. Tell us what you did at Rivian. Tell us the Rivian story, and what you learned or relearned there.
Yeah, so I ended up at Rivian in the director of vehicle launch role, which was a somewhat similar role to what I had at the time that I left Tesla.
Yeah.
And actually, when I left Tesla, I was like, I'm never, ever, 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 however many evers you want to put at the end of this, going to go back and do this again. Like the challenge of getting an EV up and running at
Yeah.
automotive scale is
Yeah.
incredibly
So you're
difficult.
Oh,
I
so
think
you
it's,
swore it off. I didn't know this. So you
yeah,
said,
yeah, yeah,
"No, you're never gonna do it again." Oh
yeah.
my gosh.
So I left. I'm like, I'm not going to do it again. I'm going to close this chapter of my life. I'm super proud of what we've done. I love the company. I love the products, but it's time to hand the baton off to somebody else, and I'm going to work on something else. And so
Okay.
I never thought that I would end up back in the EV space again, especially because a lot of I had a hard time finding the right role and the right kind of company that I thought it would make sense to do that with. And then as I a few of the people that I worked with at Tesla ended up at Rivian, so they started to talk, and so all of a sudden this started to kind of be in my at the front of my head again, and started to look at kind of what we were doing there. And one, I think the market that Rivian was entering was super compelling to me. The idea of vehicles that help people get outside and explore,
Mhm.
and leveraging the power of EV in that space, and also making them an incredibly awesome performing vehicle was super exciting to me. My other vehicle, I drive an old 80 series Land Cruiser, so I like to get outside. I like to kind of enjoy the outdoors. And so that was super compelling. It was also a market that nobody was really entering with the EV space yet, and so being able to
Yeah.
go in and do this and be really the first to market to kind of to put that stake in the ground was super exciting to me. And seeing some of the stuff that they were putting together with, RJ, the CEO, is a great guy, and seeing his vision for the company, as well as a lot of the people that I'd worked with before that were, I also highly respected and really enjoyed working with. Eventually was like, okay, well, let's go do this again. Let's get some vehicles up and running. And so I was excited to go and join kind of in that capacity. And it was, in many ways, people often like to say, hey, what's the same and what's different from, Rivian and Tesla? There's a lot that's the same, and there's some stuff that's different. Like I just mentioned, getting an EV company up off the ground and profitable and running is a very, very difficult thing to
Mm.
do. For all kinds of reasons that we could spend many more hours in this podcast has time right now to be able to discuss why
Okay.
that is. One of the things that was interesting, right, was when we went into Rivian, it's still fairly vertically integrated, but by this time, a lot of the stuff that we had to do on our own at Tesla, now there is a supply chain that exists for it. Now there is a supply chain
Interesting.
for like
Interesting.
that junction box that I first launched at Tesla. Well, now
Yeah.
now there's suppliers you can go to, and they will do that because the
Okay.
proof of EVs being a reality is there, and so there's a supply chain that you can go and kind of tap into. And so that enabled us to say, okay, we'll take away some of the complexity that we had to do, or that existed at Tesla, but then at the same time, the product roadmap had us launching R1T and R1S and the EDV 700 and all the different products.
I'll just say Rivian made was famous for the first electric, what I would call a pickup truck, but now I realize you
Mhm.
have to see it as an outdoors vehicle. But and the R1S is the SUV, right?
The
That's the one
R1S
I
is the
rode in.
SUV.
What
Yeah.
was the other one you mentioned? I
The other one's the van. So if you look
Oh,
up,
the
we have a
van.
partnership with
Right,
Amazon,
right.
right? And
I
so you've
read
got the
about it.
van.
Yeah.
Yeah, yeah,
Yeah,
exactly.
okay.
And so the launch. So what we gave up in complexity by saying, okay, some of the stuff we can go source. We said, okay, well, we actually have to launch a lot of these other products faster, so we can get them out into the market
Mhm.
quicker. We can't take quite as long between vehicles. And so you ended up with another layer of complexity, which is, okay, how do we kind of continue this launch activity at a very high level? And once you launch a product, you still have to continuously improve it kind of over time, but to you know
Mhm.
add more complexity in the number of vehicles that are getting up and out the door.
So you were there for launching all 3 of those vehicles?
Mhm.
So, what did you learn things at Rivian that were different, or did you just you said at Carbon, you kind of reinforced things. Was it a reinforcement, or did you learn things there that made you rethink some of the things or complemented
Mhm.
some of the things you learned at Tesla? Because both electric vehicles, you mentioned the difference in the supply chain availability, but, anything
Yeah.
that you
Yeah, I think one of the things that got really reinforced at Rivian, I talked about it a little bit, but this idea that what we're developing and launching a product is a system, right?
Mhm,
So, when I think about a product, like a product isn't a product until you can build it and deliver it to a customer, ideally for profit. Like before then, you can make really cool hardware, you can validate that hardware, but until you're selling it and people are buying it, it's not quite a
mhm,
product. And in order to do that, that means you need this whole system to be working in sync and ideally efficiently so that you can do that cost effectively as you're running down. And prior to my time at Rivian, like I had that concept in the back of my head as a manufacturing engineer by training, think about how you pull all these things together. But there's also this general idea that you have this, a product gets developed and then you hand it off to an ops team that builds it. And a lot of my time was spent kind of getting those two teams to talk to each other, so that way you could kind of get products up and running successfully. Whereas kind of at Rivian, it was very much like doing the same thing, but the more you do it and the more you double down on it, the more the importance of the fact that you're actually developing a system that's made up of validated designs, it's made up of parts, it's made up of supply chain, it's made up of processes, it's made up of tools, and most importantly, it's made up of people in any manufacturing system that has to run, like really kind of crystallized for me. Like that's what you're working to do when you're doing product development. And the beauty about that, especially that last item that I mentioned, people, is that they're inherently flexible. They can do lots of things. If you tell them, I need you to go work and solve on this problem, and they know what they're doing, they can often go and solve it, and they can come up with amazing results. But they're also, very flexible. If we don't have a clear idea of what we're working on or when or why, then it can kind of slow things down. It can
Mhm.
make things a whole lot more difficult. That spawned a lot of what I'm working on right now is to think about, wait, like how can we, help teams develop this system
Yeah.
and collaborate more effectively throughout these.
So perfect segue. And by the way, I'm just going to add one more little color commentary here about what you said about systems. My observation, and I meet all kinds of people building all kinds of
Mhm.
things. In fact, I'm coming up on my 50th on-site visit of the year. I'm trying to do 52, one a week this year. And so I visited
Oh, cool.
46 companies in person this year, and I have phone
Uh-huh.
calls and other things, meetings, many other ways. But my observation is today more than ever products are systems. Even, like it used to be, you'd see mechanical engineering companies making, you know
Mhm.
a single part object of some sort. Especially in the Western world now, there's almost nothing that is just a piece part being
Uh-huh.
manufactured. It's software, it's a system of some sort. Complexity has become
Yeah.
the norm. There's a lot going on. So I think your lessons are going to apply to a growing number of companies. So great segue. So what do you now? You're doing a startup, and I'm going to drum roll here. It's a secret startup, right? It's called. We can say the name, right? It's
Yeah,
called
yeah.
Threaded,
Yeah.
right?
Uh-huh.
What can you tell us about it? No secret stuff. This is a public podcast, but what can you say, and why should our audience be excited to watch the progress
Mhm.
of Threaded?
Yeah, sure. I mean, you can't say too much just yet, but kind of to layer on with what you're saying, like a lot of times, that system view that we just talked about. Like if you look, for example, at most org charts in an organization that develops and delivers hardware, you'll have a product development organization that is made up of the hardware engineering team and software engineering team, maybe a few other people, and they'll have an operations organization. And you have this idea that these are two separate things, and you'll develop the product over here, and then you'll hand it off to the operations organization, which will just build it. And what I found is I understand why it exists. Like you need organizational structure to make that up and running, but it is not quite the way that people work. Like people, you don't have a hardware development team just does what they need and then they hand it off to the build team that just goes and builds whatever the hardware development team said. You inherently have to work together to develop that system for it to be effective. And sometimes that means things have to change in the mechanical design. Sometimes that means something has to change in the tooling. Sometimes it means something has to
Mhm.
change in the supply chain, whatever. But teams get to that endpoint collaboratively and working together. They don't get to it by saying, "Hey, I've done my work, and I'm gonna hand this off to somebody else, and
Yeah,
they'll go run with it." And
makes sense.
I found that exists, regardless of whether I'm launching a tennis shoe or an EV. Like that dynamic is the same. And so, kind of what I'm working on is kind of based on the learnings that I've come through out here, understanding, wait, we've got to build this system. These aren't just discrete teams that all work in silos, and as long as they optimize their silo, we'll get the right outcome from the system, from the product. No, they've got to actually be in sync. And so, kind of what we're doing at Threaded is working to build up a software platform that can, take some of the learnings that I've found, as well as a number of the kind of problems that I talk to more and more people in space that also, experience this pain and try to create a solution to make that process more collaborative. So yeah, so we're just getting
Right.
started. We've got our website up is threadedmfg.com. So if you want to check that out and get on our mailing list, feel free to join.
I assume it would be fair to say, so you're building the system you wish you had had at
I'm building.
Rivian, at Tesla, at Carbon, right?
Yeah,
Yeah.
100%. Yeah,
Okay.
exactly. Like I've gone through a
That's
bunch of this
cool.
pain and I'm like, wait, this feels harder than it needs to be. We solved the problem over and over again, roughly the same way. Let's fix it and build the product that I wish I would have had when we started this.
Well, I'm going to recommend that our listeners do join your watch list on the website and stay tuned, because I think someone of your background committed to building better tools. I can't wait to see what you build. And that's from someone who builds tools for engineers. You've not only thought about building products, but you have built some amazing products that you've been part of, some of the iconic products of our time that you've been part of. And the idea that now you're going to bring that to a new generation of tools at Threaded, very exciting. I can't thank you enough on behalf of all our listeners for joining us, Braden. Braden Ball of Threaded, thank you so much for being our guest today on Masters of Engineering.
Well, it's kind of you
Uh,
to say. Thanks, John. It's great to be here.
That's it for today. See you next time on Masters of Engineering.